Hello world, good morning, good afternoon, good evening. Welcome to RoboThought Zero to Hero series. C++ coding in Arduino Mega, Arduino UNO, Arduino Nano, any of the Arduinos you can use for this particular series of lessons. Guys, we are on lesson number 45 and I am going to start with bunch of sensors. To begin with, we will start with LDR sensor. So what is a LDR sensor? This is how your LDR looks like. If anybody haven't seen this before, so let me show it to you. So basically, in this lesson I'll show you how LDR sensor works and its applications in IoT, in robotics and various other electronics projects. So LDR stands for light dependent resistor. So the projects uses this particular project uses a photoresistor to light an LED. So this is also called a photoresistor to light a LED, or you can trigger a relay switch. You can activate any other devices using this simple sensor called LDR. Okay. But in this project I'll show you how to write a basic code to read the information from LDR sensor and activate a LED. So basically the LED will light up whenever there is a dark or no light over the sensor. Okay, that is the way it's going to work like. Now let me show you some basic circuit, how to plug it up, right? So this is the basic architecture of the LDR sensor, how we are going to plug it into the Arduino A0 pin. So basically before that, let's take a look at what exactly this photoresistor does, right? You can call it as a photoresistor or light dependent resistor. Okay, so it is defined as a light controlled resistor, which is also called a LDR or a photoresistor. It is basically a variable resistor that controls the resistance in accordance with the received light intensity. If the light is bright or the light is dark, the resistance changes automatically, right? So it means the resistance decreases as the intensity of the light increases. Though, however, the resistance decreases with increasing proportion of the light. Hence, the output voltage will automatically increase. It also means that the output voltage calculated at the light will be higher than the output voltage calculated in the dark. So that is how this LDR activates and functions. So let's follow this particular architecture, and the way we are going to hook up our sensor is going to be like this. Okay, so you may use probably connect the positive leg of the LED, that is the long lead, in series with the resistor to the pin number 12 of Arduino board as per this drawing above me, right? So connect, and also connect the negative leg of the LED to the ground pin. Okay, you can use a breadboard and take a common ground and connect it, and connect one edge of the photoresistor to the 5-volt pin. This is the photoresistor, guys. This is the LDR. This has to go to a 5-volt pin as per this drawing on the Arduino board. Okay, the one edge, one pin, and attach a 10 kilo ohm resistor, 10k ohm resistor. That is the best optimized resistor, which will work in series with another edge of the photoresistor and connect it to the ground. Okay, as per the drawing, you can follow this. You can pause this video, plug it accordingly, and connect the edge of the photoresistor to the analog pin, which is A0. You can also use A1, A2, but I used A0. All right, so let's do some coding, guys, and make sure our circuit works. So let me show you how I hooked it up. So this is the way I have connected it. So the photoresistor, two different there is a LDR and two resistor and a LED. As per the drawing, I just plugged it. I used a breadboard with a Arduino UNO. It's a pretty simple, straightforward circuit drawing. You may follow the same. You may pause this video and take a look at the drawing. Now let's do some coding, guys. Alright, this is my Arduino IDE. I hope you guys can see. Let me do some random test. There you go. I think you can see it. Great. So let's do some coding out here. So let's define a constant input instead of a variable. Say constant int LED pin, and I have connected the LED pin to pin number 12 semicolon, and then const int. For the LDR we can name it as photo pin, like this. You can name whatever you want, guys, it's up to you. And I have connected my LDR, the photo pin, to A0 like this. Okay, and let's go to our void setup. Void setup, and close the function, open with the curly bracket, and let's say let's initialize a serial print, a serial communication. How do we do that? Serial dot begin with the speed of 9600 baud rate, like this. Okay, now what we need to do, let's go to our pin mode. Within void setup, let's go to pin mode, and what are the pin I need to read? I am going to read the, what is the name we had given for A0? It's photo pin, comma input. I am going to take the input from the LDR pin that is connected to A0, that is photo pin, and then let's go to pin mode, LED pin, and what we need to do, we need an output to the LED pin, semicolon. Okay, now let's come to our while loop. You need to come outside the block of this code within the curly bracket, and then we need to say void loop, and close the function with two curly bracket, and then open with a curly bracket like this. And within this, now let us read our sensor. So how do we read? It's int sensor status, something like that. I'm just giving any name. Sensor status equals to analog read, like this, analog read. And what we are going to read? We are going to read photo pin, which is connected to your A0 of Arduino UNO. Okay, now this will basically check the reading or status of the sensor. Now what we need to do, we need to define a if statement. Say for example, if the sensor status is less than, say, 200, something like this. If the sensor status is less than 200, then we need to do what? We need to do a digital write. Let's go to digital write. Come out of the block, and we will say digital write. Let me scroll it up. Digital write. Now what we need to digital write? We can digital write the LED pin. Okay, the LED pin, which we defined above as high. That means it will trigger one binary. That means it is on. Okay, now the LED is going to be on with this line of code. Now what we need to do, serial dot print ln. Now let's print, say, in a quote, in a double quote, we need to put a string. So LED is on. You can put whatever you want, guys. Say status of sensor is, say, dark, like this, and then close it with a double quote and close the parenthesis and make sure we put our semicolon. Okay, now let's see what we have. Now we need to put a curly bracket to close the parenthesis. Now if the LED is on when the status is dark, that is what we are getting the output. Or if it is not dark, then what do we do? So we need to use the else statement. Else, open a curly bracket like this. Now say digital write digital write digital digital write, like this, digital write LED pin comma high, which is on. Okay, now this will on the LED, and then let's also print serial dot print ln. Now we can print. No, I think this logic may not work, guys. I am sorry. We are repeating the if statement again. So maybe this will repeat into the loop. So what we will do is we will say else digital write, say LED pin is low. We will just switch it off. Okay, and then we will say serial dot print ln, and now what we can print, we will just print some say some asterisks, may star, just a blank, something like this, end with a with a double quote and close parenthesis, and most important, the semicolon. Now we need to close the curly bracket like this. Okay, what are the chances this is going to work, guys? Let's see. Constant, I haven't missed any. I hope I haven't missed any syntaxes. Let's try to compile it. Compile. There is no errors. Oh, there is an error. Alright, I missed a semicolon. Let me put a semicolon. Compile. I'm trying to compile it. Oops, there seems to be some problem with the indentation. Looks like the indentation issue. This seems to be correct. Maybe I have put an extra curly bracket. This is one big problem, guys. We got to be careful with the curly brackets and the indentations and stuff like that. There you go, it's still not accepting. So looks like I have missed it. Sensor status. If the sensor status seems to be okay, then what should be the issue? I think there are some basic syntax problem. Yes, now it is uploaded. So the syntax, guys, it's very important. If we miss any syntaxes, it's really a pain, but the good part is we get a red error here at the bottom, and you can go to that exact line and try to fix it. All right, now let's try to upload. Compiling again and trying to upload the sketch. There you go. It's done uploading. Now I don't see any output, but let me try to open the terminal and oops, there you go. Great. Let me just share it with you guys. So, okay, where is the terminal? I hope you guys can see. So let me just block the sensor and check what we get. If I make it to dark, I don't see any output, but looks like the LDR is reading for sure. It's not taking any variable input though, but let's see. Yeah, I think now it is taking up. Looks like there was some loose connection maybe. Let me just try to, there you go. I think it's taking the status. Can you see if I close the LDR, it's just reading. Yeah, I can see the LEDs blinking. Let me just show my circuit video. See, I'm trying to expose this to the light, and then let me just try to close it. There you go, the LED glows, and in the terminal you can see the serial print, whatever the command we gave. And when it is dark, when there is a light exposed onto the LDR, the LED goes off. When we make it dark, see the LED glows, and you can see on the terminal. Let me take out my hand. So LED is off because the light is getting exposed on the LDR. And then let me just close it. There you go, the LED is on. Now let me go back to the terminal again. Let me close the LDR. Alright, there you go. Can you see? LED is on, LED is on, LED is on, LED is on. That's good, pretty good. Alright, so guys, these are some of the basic principles of LDR, the way we are hooking up the LDR and trying to read the environment outside. When the light is bright or it becomes dark, we throw an output. So it's a simple logic, it's a simple logical programming and hooking up the sensors. So I hope by this time you guys are getting hands-on with connecting the sensors and reading the pin using analog input, and through the digital out we can terminate several other outputs. So going forward, I'm going to show you a bunch of other sensors. We will slow and steady take it forward from there. So once you guys are hooked up to the sensors and start reading and writing your code, it's going to be fantastic, guys. That means you are almost 50% there, and by end of this series, probably another 10-15 lessons, we will take this entire Arduino series and connect it with our Jetson Nano series. We will start building a big huge robot which is behind me. You can see that, and it's going to get more interesting. All right, guys. So do give me a thumbs up and a like, and I'm going to get back to you soon in the next lesson. See you. Bye bye.